there's some stuff that I won't be able to cover for the 2, maybe 3 people that's like don't know everything about Git. I know this is like a beginner's tag, but I'm going to try to go over some stuff. I'm going to try to go over the stuff assuming a beginner, but like there are things that I can't cover that are, well, there's only so much time. So how many people know what Git branches are? Okay. Can somebody try to like a little bit describe what it is, what a branch is?
And you copy what you already have, and then you can modify stuff on the branch that doesn't usually make a branch.
Yeah, exactly. It's like almost like a parallel universe, right? Like you can do whatever you want in one side of the universe, and the other universe is left untouched. And then eventually, if you want to, you can like merge them back together, so that anything that you've done in one universe gets included in the new universe or the master universe. So usually by convention, every time you start a Git repository, and when I say repository, I just mean anything that Git is following inside a folder. So like if you have a project, let's say like research, your research folder, and inside your research is a particular project that you're working on. And so that would be considered a repository if you have Git following it. And I'll go over that in just a second. So other than that, the main advantages to using branches is if you want to like do some experimental stuff, the biggest thing is for collaborative work. If you're doing some stuff with like more than 2 people, branches are really useful because then you can branch off, make changes to the files, and then not have to worry about touching the master branch that everybody else is using. So like let's say you have a data set that's under version control of Git, and you don't want to touch that master branch because other people are using that data set, right? But so if you want to fix that data set, you can create a branch and then eventually merge it back into the master data set. If you're like a solo person, then using branches aren't as useful. But sometimes you want to like make some experimental changes to your manuscript or your thesis or something or your code, and you don't want it to influence what you're doing right now. Like let's say you just were like, I'm just going to do this. I feel like it. I want to see if this is going to work out. You can make a branch, go off, do whatever you want, and then eventually you can like, if that works out, you can merge it back in. Otherwise, you can just delete it. Now, the best way, well, I think the best way of understanding how branches work is visually. And so there, if everybody could go, if you just go to Google, and you go to explain with D, and then just click that first link there. So inside this website is there's this little link called Git branch. So if you click that, and then we're just going to scroll down to here. A lot of these commands that I'm going to be showing, you can't really see that.
Contrast will probably be higher once you start typing. What's
that?
I think once you start typing, it does it in the
yeah. It's right at the bottom. But when I press enter, it'll go up to the top, so you can see me entering the commands. So just to, for the people that don't know Git very well, I'm going to be using some commands that you might not understand, but that's okay. I'll explain it afterwards when we try it on your computer. But just to visualize what a branch is doing, I just want to show you this. So if you do git branch command for making or using branches, and then just type out new branch. Now you see here, when you do git branch, new branch, so git branch is the command, and then new branch is the name of that new branch. You'll see here that there's 3, so this is the first commit, within the history, within your repository. And a commit is just like a saved state of your project. Now master is by default the branch that Git makes automatically, and then head is wherever you are currently located. New branch is then that new branch that you created. So you can move over to the new branch by doing git check. So you see how you've now moved over to this new branch. So git checkout just is a way of moving across your Git repository. Now, and you can just add whatever, just doesn't really, at this point in time, this doesn't really matter, the commit. It's just to show you what's going on here. So if you just type out git commit -a-m and then the message, you could even, I'll try it in a minute, but you see here that the new branch is now one ahead of master branch. Now, a key thing about Git, is anybody aware of what a directed acyclic graph is? Okay, a directed acyclic graph is exactly this. You have a node, this is a node, and then you have a so-called edge. And so directed means that there's an arrow pointing in a certain direction, and acyclic means that you can't have you can't have the arrow going both ways. It's only one direction. Now Git stores all of the commits using this directed acyclic graph. What that means is that every single commit has a parent, and every commit can also have several children. When you get into merging, the commit could have two parents, but generally they only have one parent. So this commit here is the child of this commit. All the branch is doing is just pointing to this particular commit. That's it. So oftentimes it's said that the Git branches are cheap. And by cheap, I mean like when you work on your computer, it's fast. It doesn't take up a lot of disk space, only because all it's doing is just pointing to this particular commit. So if we go to git checkout master, see now this commit has two children, and each children is under a branch. So all the branch is doing is pointing to the children. So let's do git. So you move along. Now there's another child with one parent and one parent. And you have two branches now. So the master and the new branch. If at any question, just jump in. Now, go to, let's do, now the nice thing about having these branches and being able to like create experimental branches or feature branches or a bug fix branch, if you're working with software or whatever, you can then later on merge them. So if you do git checkout, git merge, every time you do a merge, whichever branch you're on, it takes whatever was inside, every change that was inside of this branch and puts it now into this new commit. So now this new commit has all of the changes at these commits as well as this commit. So it now has two parents, right? Now you can even keep going.
Well, what if one commit was changing like information? Say you deleted like half your file in the master, or I guess in the new branch, and we merged them.
Then you would get into a merge conflict.
Okay.
And I can show that in a bit, but a merge conflict is when, like Sarah is saying, problems, like maybe one file has a line that was changed, and in the same commit, there's another file that had also the same line changed. And so Git says, hey, there's problems, so then you have to deal with this. Now, this is the basic structure of how Git branches work visually. Because when you actually get into the command line, you can't see it all pretty like this. It's ugly. So I'm showing you this just to get you to have like a visual understanding of what is going on within Git. But then once you get into the actual Git terminal, you can't, I'll show you, but it's very ugly. It's a lot more ugly than this. Now, before I get into the terminal, does anybody have any questions about this? No? You have a question? No? Okay, yes.
Yeah.
Does everybody have Git installed? Yes, good. So if you can go into your terminal.
It's not a very smart visualization.
Huh?
It's not a very smart visualization tool.
Which one?
Oh,
Oh, the D3 one?
D3,
No, yeah, it's basic. It's basic. It's just for,
overlaps.
yeah.
All of it.
yeah. It's very basic. It's just to show you the concept, right?
Yeah.
So if you go into the terminal, I want you to do cd desktop. Is anybody who's familiar with bash commands? Put your hand up. Okay, so that's fine. Do you two know how to get into bash or get bash? What do you can help? Can you help her too? Him too? Both? Have you opened it up?
Yeah, she was.
Okay. Okay.
I guess you can say that there are graphical tools to do it, but
Yeah, there are graphical tools, but
there's more direct control.
with the command line, yeah. There are some of the GUIs. Different GUIs have different strengths and weaknesses, and like some just suck for a certain thing, and some are better for others. Command line is the best, at least for Git. So CD stands for, yeah. There you go. So now we're going to make directory. So mkdir, which is make directory, git branches. What I did there was just I created a new folder called git branches on my desktop, and then I just moved into that folder. So then do git it's a new repository. So git init just stands for initialize, and so this is now a Git repository. This folder. Git. Okay, so what I've done there is I've just added everything. There's nothing there right now. So if you do git add dot, that'll just add everything inside the repository or the folder. And then just git commit so you have a first commit.
I think you actually need to have something.
You have to have something?
Yeah. So if you just say touch.
Yep, you're right. Yep. So touch readme. Huh? Git commit. Oh, git commit. I'll just do this for now. There we go. So all touch does is just it creates a file within the directory, your git branches directory, and then git add adds that to the git repository, and then git commit puts it into history.
So everything in the quotation is the message that you're telling Git to like, it's a way of
Yes.
jotting down a note of what your commit is.
Yeah, -m just stands for message. Thank you. Got my back. Okay. Itself, you'll see that there's one branch already there, master. And this is always by default, there's master branch. Now, yes, it'll show all of them.
With an asterisk inside which one you're.
Currently on, yep. So let's create a new branch, git branch, new branch. And then so we've created a new branch and we've moved over into that branch. So git checkout just moves into that branch. Git. If you do git branch again, you can see that there's now two new branch. Well, there's a new branch, and you're on it. So there's a little asterisk, and it's colored. And then there's also master. So if we do echo, now echo is just saying print to screen, but then when you use this little redirect sign, it says put this text into this file. So when you do git status, does anybody know what git status does? No, most of you know what git status does. For those who don't, does somebody want to tell them?
It shows everything that's like committed, maybe that's changed.
Yep, exactly. Everything that's going on inside of the repository. So you can see I've changed this README file. Now, if you do git commit README, git commit just adds, so since you've changed this, if you do git commit the file that you've changed, that will put that into the history. So if you do git log, now this is a way to visualize what I was talking about. It's kind of, actually before we do that, back to the master branch, right? Do So if you do git echo other text and redirect it into the README file, you'll see now that it's been added to this README file, but you're in the master branch now. So if you try to remember the visualization, there was in the new branch, we added some text into the README file. And now we've moved over to the master branch and we've added other text to the master branch.
When we move over to the master branch, the README file became empty.
Exactly, yeah. So if you look inside of the file, inside of the README file, actually you can do git diff README. So git diff just looks at the difference with the file that's inside that's currently been changed. So just, you can see here that this has been added. It was originally empty, and now it's just been added. Other text has been added. Yes, yes.
Yeah. You can specify what commits to do it. So by default, it compares your head to the actual.
So now I've committed now the README into the history. So now you have a commit in the new branch and a commit in the master branch. And they're both pointing to the initial commit. So if you can picture that inside your mind. Now there's a way to visualize it inside here. It's a little ugly, but it's something. Decorate one line, all graph. You have to press Q to get out of the exit. Q for quit. So git log, decorate one line all graph. That just makes it prettier to look at. Otherwise, it's really ugly. But you can see here, there's asterisks here for master. That's where the commit is for master branch that you just added some other text. And then there's this other asterisk here for the other branch. Now you can't really see it that well, but there's 2 lines that point to this original commit. So this is the parent. See how I said it's kind of ugly? And then as you get a little bit more complicated, you have more like branches or like more people working on stuff. For example, this study group repository, it's very complicated. And you'd see like lines going all over the place. It was just a little bit of a mess. But at least here you can kind of see what's going on. And if you're working on a simpler project, you can like visualize what's going on. Now there's a way so you don't have to type all of that out every single time. So you can, if you do git config alias.lg, I'm going to do LG2 because I already have an LG. And then log decorate all graph. Now what that does is, does anybody know what's an alias?
Another name for something?
Yeah, another name for something. So rather than having to type out log, decorate, one line, all graph, you can now just type out log2. So if we do git log2, it does the same thing.
So anytime, and then if I make more commits, like this will update on that, so it is.
Yes,
Yeah.
because it's been added to the global, because you have the double dash
Yeah.
global.
And so the reason why you do global is that will work in any repository on your computer.
It's really useful.
If you didn't have global, it would only be in this one repository.
Is everybody good so far? Ish. How are you doing?
Well, I'm following what you're doing, but
Is it different?
that's
Is he okay, Leo?
not really like it's exactly as
Oh,
so trying to follow it.
okay.
Yeah.
Gotcha.
If you don't understand, yeah, it's kind of hard.
It takes a little bit, but
Yeah.
Go to that, like, the visualization website, so you.
Yeah. So
if I've put in, so if you go to the where is it? You go to the U of T study group website, and then in the lesson content, it's the like everything that I'm kind of talking about right now is inside using branches in Git. So if you just scroll down, and there's at the very bottom here, there's a link just to some websites that you can use to help understand this a little bit more.
Go back to the lesson content, what was the more on Git?
More on Git
Oh,
was,
we didn't have an intro to Git on here, so. What?
yeah.
yeah, there's an intro to Git, yeah. That was like the first one of the year.
Yeah, well.
And then more on Git, Elliot taught that one. Okay. So if you remember, there was some text in the README file of the one branch, and there's other text in the master branch. So Can anybody predict what's going to happen if I merge the two files, the two branches together? What's going to happen? You're going to get a conflict. So if you do git merge,
I wonder, could you make a one file that doesn't conflict so we can see that?
that's okay. That's a good idea. Okay, so if we do echo new file, add it to fun.txt and git add fun.txt git commit added. Now all I've done there is just added another commit to the master branch, and I'm going to do something else next. Let's check out branch. There's little stickies to say whenever everybody is caught up. So if you do git log 2, you now see that each branch has 2 commits, each, and we're right now at the new branch. And you can see here, this commit is the parent of this commit, or rather, this commit is the child of this commit. And this commit is a child of this commit. And then both of these commits are the children of this commit. So if we do git checkout, so git merge new branch. Uh-oh. Now, if you've done everything similar or almost the same as what I've done, you should get a merge conflict. Now, if you do git status, there's this new file, whatevs, that was from the other branch, the new branch, if you remember, created in the other branch. So it's waiting to be committed. It hasn't been committed yet because there's a problem with this. So you can see unmerged paths says both modified read.txt, readme.txt. So if you do git diff, or even actually just do cat. No, wait.
Or any editor.
Probably Nano. Has anybody used Nano before? There's a couple of people that have used Nano.
Or you can just use Notepad.
That's true. Oh, does Windows have Nano?
Nano is definitely Linux, and it might get included.
Do you know? Who's using Nano? Doesn't come. Okay, so if you just do Notepad, README. I don't have Notepad, so I can't do that. But if you do Notepad, replace Nano with whatever.
Basically, in any text editor, open up the README file.
Exactly. In any text editor, open up the README file. Now what you should see is this. There's like these like multiple equal signs, greater than, less than symbols, and it says head, and then it says new branch. Now head indicates the master. Has everybody been able to open this up? Yeah. This is the conflict. This is what Git does when there's a conflict between two merges, between two branches. And so this is basically Git's just saying, here's a problem, you need to fix it, human intervention, help me, whatever. Because Git can't deal with this. So it's your job to be able to say, okay, what do I want to keep and what do I want to get rid of? And so you can do that by just deleting this. Let's say I don't want this other text. I want to get rid of this. You have to delete these. Okay. Now I got rid of other text and I kept only some text. And then you have to get rid of all those like equal signs, whatever. What's that? Oh, yes, thank you. I didn't see that. There we go. Now if you do, if you're in Nano, you can just do Control X, Y for yes, for save, and then just enter. Now if we do Git, now you do Git add, readme, Git, what's going on. Now you've changed this, and it's ready to be committed. So you fixed the conflict. Now you can do Git. Now if you just press Git commit, I don't know if, for me it'll open up my, what I've specified as the default editor. I don't know if other people have whatever they've had as their default editor. Yours Nano? You do have Nano? Oh, okay. Oh. And then you can just like save the file and then close it. It's status. Okay, it's empty. So if you do git log. So now you can now see that the new branch is still here, and it's been merged into the master branch. So now you have everything that was inside the new branch, as well as everything in the master branch. Because if you do ls, or just ls. Oh, sorry. Oh yeah, sorry. There. So you do git add, then git commit, and then save the whatever opens up, save it, and then close it. And then it should then put it into the commit. And then you just do git log2 or lg2. And you can see this. And then if you do what? How do you get a
escape, colon, so you quit the escape, then colon, and then W
or QA
or X.
or X?
Yeah, it's
So ls is just showing everything that's inside the folder. So you can see there's the fun.txt, there's readme, and there's the whatets. So everything that was under your two branches is now all together. Now, one particular purpose for using branches is with pull requests. I don't think I'll get you to do this. Before I do that, does anybody have any questions? Does anybody want me to go over more? Or yeah, if you're confused.
Yeah.
That's usually the case. You can't figure out anything in an hour.
Yes.
It's like, this is just an introduction. Be like, hey, this exists. Okay, find out now. Learn on your own type thing.
What would happen if I started working on a new branch?
Okay, so if we were to go to the new branch, now if you do now this double redirect just says append it to the bottom of README. So you're not replacing everything inside README. So now if you do git commit, added to dude, this is where it gets like really ugly. It takes up like 3 spaces just to show you that
Oh,
the master branch is over here and it's been merged, but that now the new branch has been put up. It's like really a little bit ugly.
Is that matter, like, if you change to your master and do this again, is it gonna look different?
It's gonna look different,
And-
yeah.
And it's always on this for this one.
It's gonna look different. You're right.
It's
Actually, no, you're-
It's based on time.
That's true, yeah.
Oh, okay.
My mistake, sorry. So yeah, the commits are just, if you think of like commits as just, this is one reason why Git can be very fast, and also why like all that branches are just pointers is each commit is just a sheet of paper that's kept on being added to the top and top and top and top. And the only thing that separates them is a pointer to the previous commit as well as the timestamp. So whatever's the most recent is always on the top of that stack of pile. But you can always move around. And then so the Git branch is simply just a pointer to a particular point in that stack of paper or stack of commits. And then if you wanted to, you could then do git merge. And then git log. So now you can see you made a change in the new branch, and then you go back to the master branch, then you merge, and then now it's taking whatever you've done in the new branch and it's now put it into the master branch. Now, if you wanted to delete the new branch, you could just do git now it's been deleted. So the pointer has been deleted. That's all it is, right? A Git branch is just a pointer, and so you've just simply deleted that pointer, but the commit still exists. It's still inside that stack of paper. See, it's still there. Each commit has a parent, and each commit can also have multiple children. They all, like, if you kill off a parent or a child, like, it's not, well, anyway, like, it's not gonna just disappear, right? The commits all stay there, but now you just cleaned it up, so there's only one master now. So if you do like git branch, there's just master now. Now, oftentimes that's what you want, is just to keep it fairly clean and have, like, that's the nice thing about branches is they're very cheap. You can just do changes and then merge it back in and then delete it, throw it off to the side. You don't need it anymore. And even inside GitHub, there is, every time you do a pull request, there's like an option to automatically delete the branch that you've just merged in for the pull request. So it's just cheap. Once it's used and done with, you throw it out. Doesn't matter. So I'm just going to show an example of.
Is there a flag for that when you merge it?
What do you mean?
Like, you get merged something?
That's a good question. I'm not sure. I've never used that. I don't know if if there is. I don't think so. No, I don't think so. You have to actually directly delete it using the Git branch. So you don't have to do this. I just want to show you an example of when you'd use the Git branch in a pull request. So I'm going to go to story group, Tcores, sandbox, fork. Oh, it's already forked. I already have it. Sorry, 1 second. So what I've done is every time you do like if you're working collaboratively with more than 2 people on a project, you're probably going to have a forked version of your main thing. So like, for example, the sandbox, there's the U of T Coder sandbox, and then I forked it so that, and fork just means a copy of, make a copy of on GitHub. So now you have, I have sandbox and the U of T Coders has a sandbox. Now what I just did there was I've cloned it down onto mine, and clone just means download it, essentially, into my computer. And so you can see, let's see. On here is the sandbox on my computer. Now let's say I want to change something. So I make a branch in the short out -b, and then I'm just going to call it. And that's a new branch. So you create a new branch and you go to checkout, and then I'm just going to do echo test into Git added, then all these steps are on the website, so you don't have to follow along. I'm just trying to show you the concept of it. Origin. Okay, so just to show you what I did. It doesn't show here with the git clone, but I cloned it and then I moved into the sandbox. And then I made a new branch called plain. I created a new file called playing around with the text testing, and then added that to the commit, added that to the repository and then committed it. And then I pushed it up to my branch. Sorry, my forked version on GitHub. That's what Origin is. Origin is always your own version, your own forked version on GitHub. So if we go to GitHub, and refresh, it says you can see there, it says, you recently pushed branches playing up, and you can see it automatically tells you, oh, do you want to compare it, and then do a pull request. So then you can go into, so you can click that. Might take a little while. And then make a new, and then create the pull request. And then depending on, so there's already pull requests here. So depending on whatever happens, I can just say, okay, I'll just merge it in. So I'm going to merge it in.
Now, you're now on the,
Yes, sorry. Yes, you're right. So now I've switched over to the UT Coders sandbox. Now, because I have administrative privileges on this, you, like most people, won't have the access to merge this automatically, but I can merge it automatically. But whoever is like the organizer or like whoever has access to the main repository, they can merge it in. It's kind of like being a gatekeeper. You just don't want anybody to merge in stuff into your work. You want to be able to say, okay, here's a little bit of quality control. I want to check to make sure your code or your text is good, and then I'll let you incorporate your stuff into my whatever it is, code or manuscript or. So I'm gonna do merge pull request, and then here you can see it says right away delete branch. So I can delete the branch. So I just do delete branch and it's done. It's deleted on my end. It's incorporated into the main data set, main repository. And if I want to get rid of it on this end, on like my computer end, I have to do git pull upstream. Oh.
that's origin.
1 second. Got to first check out. Go back to the master and then do git pull. Now I didn't mention this, but git pull upstream, you have to set this yourself, but upstream usually just means not your version of the forked repository, but the original version. So it's kind of like upstream of what you have, if that kind of makes sense. This is just by convention, like you can name it whatever you want, but just by convention, they're called origin and then they're called upstream. If you change it to whatever you want, like it's up to you, but people won't maybe understand what you're talking about. See, upstream does not, I don't have upstream.
Yeah, you haven't set it as a remote.
Yeah. So I think git remote add upstream. Paste. So git remote add upstream, you're just adding the remote upstream. Now I can do git pull upstream. What is it? Master. And then git, what's the next part? Oh, right. Git branch delete, and then I delete it from my end. So now you have just a single branch now. So you've done your stuff, you've incorporated into the master branch, or you've done a pull request, and then you've cleaned it all up. I mean, like if you're working with other people, it's good practice. I personally don't use them often unless I'm working with other people. Usually it's just like I just have a master branch or whatever. A side note, if you want to make use of, so GitHub has these things called GitHub pages. So if you want to make your own GitHub page, or if you want to make your own website, you can use GitHub you can use a Git repository to make this website. And so if you have to change your branch name to gh-page, so for GitHub page. and that automatically tells GitHub to take everything on your GitHub repository and create it as a website, which is really cool because then it's free. It's completely free. So it's really useful if you just want to have something like to like blog about and you don't want to pay for hosting and like SQL backends and whatever PHP stuff that you have to deal with. It's just GitHub, your blog. Any questions? Yeah. Take some snacks. Make sure you eat the oranges. Did I